In the previous tutorial, we covered how to blink an LED using one of the digital pins on the microcontroller. This is because a digital pin is capable of providing digital output. In other words, either a high state, or 3.3 volts, or a low state, or 0 volts. There is a limitation to this, since sometimes you want a value between 0 volts and 3.3 volts. Now, this microcontroller does in fact have one digital to analog converter that can generate different voltage outputs between 0 volts and 3.3 volts, but there is another trick you can do with digital pins to create a value that is pseudo-analog. If you flicker the digital pin fast enough, on average, the voltage will be roughly some mil value. Now, you won't get a true analog value, but thankfully with light, your eyes can't pick up anything that flickers faster than 60 Hz. So, if you flicker the LED extremely quickly, the LED will look like it's slightly dim. Also note that this method works great for anything that cannot respond fast enough to pick up the quick flickering, like motors, since they take time to accelerate and decelerate. Really, you could just quickly write some code that turns on and off an LED really fast, but there's another method you can do instead. This method is called pulse width modulation, or PWM for short. The way this works is by having a repeating pattern of on and off flickers, and the rate of flickering is dependent on the pulse period that you select. You can also adjust the duty cycle, or the percent that is on in each pulse period, to define what the value on average it will be. The greater the duty cycle, the more time it is on, and the lower the duty cycle, the less time it is on. By manipulating the duty cycle and the pulse period, you can effectively make an LED gradually get brighter and dimmer, or a motor rotate faster and slower. So in this tutorial, we'll be using PWM to do this, so let's go ahead and get started.
So thankfully, mBed has some nifty functions built in to be able to handle PWM. So we're going to use that to sort of instead of a flickering LED, we're going to make a smoothly sort of pulsating LED. So we're going to start off by including the mBed header again, like we always do. But now instead of using a digital out, we're going to use the PWM out class, which is provided by mBed. It has the exact same syntax as the digital out, but it's going to use PWM to render the output instead of just setting the pin to be high or low. So we'll call this LED PWM, and we're going to put it over on the PTD D2 pin. So in our main function, our main entry point, we're going to start off by setting the period of the PWM using a member function of this object, which is going to be LED PWM dot period. This is going to set the period of this particular pin. So we want to set it to 100 cycles a second, so that will be 0.01. The reason why we're doing this is because we're not going to use any smoothing filter on the other end of the digital output. We are just going to do raw PWM on the LED. But your eyes will naturally sort of smooth what it's seeing between the high and low parts of the cycle. So if we cycle it fast enough, your eye will sort of create the intermediate value, even though all we're doing is having it just go on or off for the LED. So now we will start off the LED at 0. And it's going to use the exact same syntax that we had for the digital out pins of just saying that the pin equals 0. But instead, you'll see that it is a float instead of an integer, because it can't just be 0 or 1. It can actually be anything in between 0 and 1. So now we're going to create another while loop to have it go forever. And we're going to make a for loop that's going to start off at 0 and make sure that we're less than 1, because the values for the PWM are clamped between 0 and 1. And it's going to step up by just a little bit each time. So we'll say by 0.05. Now we are going to set the LED to be whatever our value is, and then we're going to again pause, have the processor pause a little bit, say 1/20th of a second, in order to be able to not have it just flash ridiculously fast. And then we're going to repeat the same thing to have it pulse downward. We're going to have it go backwards. So we're going to start at 1.0, and we're going to decrease, make sure that we're always greater than 0.0, and we're going to decrease it every cycle. And we're going to do the same thing, set the value of the PWM to be the value that we're iterating through, and we're going to pause a little bit after each cycle. So this program is going to create this PWM pin, and then in our main function we're going to set the period of the PWM so that our eyes will not be able to tell individual cycles. Start off the LED off, and then we're going to loop forever this loop, which is going to start off at 0 and ramp us the value of the LED up until it hits 1, and then this loop, which is going to start it off at 1 and then ramp it back down, and repeat that over and over again. So now that we have this written, oops, looks like I made a typo. Sorry about that. This is not pause. That's not the name of this function. This is actually wait. It's very important to make sure you remember the names of the functions that are system functions like this. If we had left that as pause, it would have yielded a compiler error. Good thing I caught that. So this will work though. So now that I have that written, I can hit select all, go ahead and copy that code so that I can go over to mBed, the online compiler interface in my web browser. I can paste that into the main.cpp file and just hit compile here, and it should go through, love everything, and download my new binary. So now that we have the binary, we can just go ahead and go over and open up our downloads, and it should be there. This is the one from the previous tutorial, but here the -2 is the new one. And once again, we can just drag this over to the mBed disk there, and it will automatically upload it to the device.